Hello, today we're going to do a 3-variable PVnT table. The other two that we did were just 2 variables. Now we're going to try 3. We're going to think of a balloon. You buy a balloon to brighten a friend's day. The balloon in the store is at a pressure of 15.68. 15.68 psi and a temperature of 291 K. Remember, we have to be in Kelvin because Celsius doesn't work. And the volume is 3,000 milliliters. 3,000 milliliters. You take the balloon outside where it's going to decrease its volume to 1,000 milliliters. And then it says that standard temp. Well, standard temp is 273 Kelvin, standard temp. And we're trying to figure out the pressure. So we're trying to figure out the pressure. So what we're going to do, and the number of gas particles, that is constant because we didn't put any more into the balloon after the initial was put in. So that is constant. The temperature, as you can see from 291 to 273, that is going down. The volume from 3,000 to 1,000 is also going down. So we want to look at pressure in regards to temperature and pressure in regards to volume. We have to do them separately. So let's just take pressure and temperature first. So if we look at temperature, we're going to draw particle diagrams again. We are making volume the same, and we are also making number of particles the same, constants. I know that volume is decreasing, but when we're only looking at pressure and temperature, that's the only things we're looking at right now, the volume is the same. So we're going to do 3 particles in here. 3 particles. Because our temp is going down, initial and final, our temp is going down. So initially, our arrows are going to be really big. And then in the final, they're going to be small. So as temperature goes down, pressure also goes down. So as temperature goes down, pressure is also going to go down. And we're going to do that PT. For pressure is going down when we have temperature, when temperature goes down. Now we're going to look at pressure and volume. So I'm going to do that over here. Pressure and volume. And we're going to assume that N and T are constant. We're going to assume that N and T are constant. So with this one, we know initially we have 3,000 and finally we have 1,000. So our initial is going to be big and our final is going to be small. We have the same number of particles, and because T is constant, we have to have the same length of arrows every single time. Well, here, if we decrease if we decrease volume, we also have to decrease pressure. I'm sorry again, I totally misspoke there. We have to increase pressure. We're increasing pressure because there's less room, so the particles are hitting the sides of the wall more often. So we're decrease volume, increase pressure. So over here, when we decrease volume, we have to increase pressure. And I'm going to call this PV right there. Now we can do our calculation. So we're going to take 15.68 psi. And let's do pressure temperature first. We want the pressure for temp to go down. So that means that for temperature, that means that the smaller number, 273 Kelvin, needs to be on top. 291, 273. Pressure for T to go down. We also, I'm going to write this a little bit better because this was not written well. So this is 291 K. We also want for pressure and volume, pressure for volume, we want that to go up. So on our pressure right here, we want our pressure to go up for volume. So that means that 3,000 is on the top and 1,000 is on the bottom. Milliliters cancels, K cancels. We're going to take 15.68. We're going to multiply it by 273. We're going to multiply it by 3,000. We're going to divide by 291. We're also going to divide by 1,000. And we're going to get 44.13 PSI.